Hi everybody and welcome to the final video in the Deep Learning Audio Application from Design to Deployment series. This time we're going to be deploying into a server, an AwS server or a speech recognition system. But let's take a look at what we did last time. So if you guys remember, last time we introduced Nginx in front of our Flask UWSGI application, and then we containerized Nginx and Flask into like two different Docker containers that can talk to each other thanks to Docker Compose. Now, the final thing that we want to do is to take all of these goods and deploy them onto AwS. So here is like how the final architecture of our system is going to look like. So regarding AwS, we're going to be using an EC2 instance, and specifically we're going to deploy on a Ubuntu server. Okay, so let's get started. The first step here is to get into our code base. Now here I'm in this folder like 8, because this is like the 8th and final video of the series. And here we need to restructure a little bit like what we've done so far, so that we can separate between the things that we want to keep just like on our local machine and like all the other things that we want to deploy on our server. So I'm going to create a couple of directories here. So one I'll call local, and the other one I'm going to call it, where is it? Here, server, right? Okay, so what should we keep here in local? So client, like this is like the script that we use to hit our server, and we want it like on local. Then the test, which has like some audio files like for testing. And then we are going to keep here the dataset and the classifier, because yeah, we don't really need to like know the dataset, neither the classifier like on the server, because these are all things that we'll be doing like here on our local machine. Good. Okay, so we can take this and put them into local. Okay, we'll do this refactoring. That's all good. Yeah, let me just close these files. And then we are going to take this Nginx directory, the Flask directory, and the Docker Compose file over here, and put all of these guys here into the server. Okay, this looks like really good. But now let's just like close all of these files. We don't need them for now. So basically, like what we want to do is take like so once we have our Ubuntu server, just like take like this server folder and copy it into like the server itself. But now let's take a look at one final script that we should like create here, and it's going to be like a shell script, a bash script. And we're going to use this for initializing the server. So now there are a couple of ways that you can go around when you want to like initialize like a server, just like start like your application on a server. One is just like typing all of your commands directly like from the command line like in the server after you've SSH'd into like the server. Another one is just to create a bash script where you put all of your commands and then just run that script, so that you don't have like to type a lot of things like in the terminal. So I think like this is like a way better like way of like doing this kind of like initialization, and so we're going to use this. Okay, so let me create a new file that I'm going to call init.sh. Good. Okay, so here as the first thing, I just want to like use this shebang like symbol, and then say that the interpreter that we want to use is bash, right, for running the script. Then here we're going to do like a bunch of things. So the first one is just like to download, or I should say install Docker. Then after we've installed Docker, we want to start Docker service. Then we want to install Docker Compose. And finally, we want to build and run Docker containers. Good. Okay, so before starting from like this installing Docker, let's just do something that we should always do when we are dealing like with a new like server. So just do a apt-get updates. Right, so this way we're gonna just like update all the repos in the server. Now, obviously, like here I'm using like Bash because we're gonna be dealing with a Linux server, right? Okay, so to install Docker, we can do sudo and then do apt install, and then we can do docker.io, and this will install Docker, and then we need to start the Docker service. And so for doing that, we'll do a sudo system ctl, and then should say start Docker, and this will start a Docker service. And we also want to do a sudo systemctl enable Docker. So with this instruction, basically we are telling the server that we want always to like start the Docker service whenever we boot. Good. Okay, so now we need to install Docker Compose, because like if you guys remember from last video, Docker Compose is the one that's responsible for creating a Docker network where all the containers can talk to each other. So now, if you don't remember that, just like go watch out my previous video. Okay, so to install Docker Compose, we can just like come here, like this is the Docker website, and this is the install Docker Compose web page. So here we'll just move on to Linux. Okay, and here we have a couple of commands that we should copy. So this command just like enables us like to download like Docker Compose, and then the second command over here basically change the way like we can access the Docker Compose file over here, and it sets it to an executable so that we can execute Docker Compose. Great. So finally, we want to build and run like the Docker containers, right? And so first of all, we should be sure that we are like at the level of, so we are like here, like in server, right? So we can do call directory and then just say server like this. Okay, this is because like potentially we can run the script from anywhere, like in any path, like in our server, right? And then the last thing that we want to do is a sudo then docker compose build and sudo docker compose up, right? So we saw this couple of instructions in the previous video, but there's a shortcut here. So we're going to save one line of code. So we can merge these two instructions by saying docker compose up, and then we put like -- build. This is equivalent to those two instructions. Great. Okay, so now we have our init script, a shell script that we are going to run in the server. But now, obviously, we need to like create the server like an EC2 instance. So to do that, obviously, we'll need to go to AwS. Now, if you don't have an account with Amazon Web Services, then you should just like create one, sign up. We're going to be using the free tier that offers a year, I believe, of like free computation. Like obviously, like it's limited resources, but it's great to get started. Okay, then if it's the first time that you're dealing with AwS, it can feel a little bit like overwhelming because you have a ton of features and things. The ecosystem is very large, but what you should do is just go to the EC2 dashboard here, and then from here we can launch like new instances. Okay, so here we can launch a new instance. Okay, so when we launch an instance, we should like provide like a few settings. So the first one that we should provide obviously is the operating system that we want to use. And as you can see here, so Amazon provides us with all sorts of different OS options. So Amazon Linux, Red Hat, Ubuntu, Windows servers. And so as I mentioned, we're going to be using Ubuntu Server 18. So I'll select this, and here we should like select what type of like machine we want for our instance. Now here you can find all sorts of machines, from very small machines like this T2 Nano all the way up like to this like BIST machines down here. But as you can see here, we're going to be using this T2 micro instance, which is eligible for the free tier. Okay, so here we can do review and launch, and we do a launch, and okay, so this is like an important thing. So now the way like we log into like our Ubuntu server is going to be through a key pair, right? So Amazon is going to store a public key, and we're going to download a private key that we can use to access the remote server. So here already I have like a key pair, but I just want to create a new key pair so that you guys like can see how the whole thing like is done. Okay, so the key pair name, so I'm gonna give, I don't know, let's call it speech recognition. So this will be the name of the of my private key, and I can download the key pair here. Okay, so I've downloaded that. That's great. Okay, so now I can launch the instance. Okay, so we can view the instances here. So like in this screen here, you're gonna see like all of your like different instances that you have like running, or just like in any state really, and you're gonna get like a lot of like information down here regarding like your instances. Okay, so here we are still waiting like for this instance to be like up, but in the meantime, so we want to start copying stuff like into like the server now that it is running, as you can see here. So how can we do that? Well, for doing that, we're going to use SCP, and for logging into the server, we're going to use SSH. So let's fire up a terminal window, and here, so the first thing that I want to do though is just to go here to this downloads, take this key, and then go back here, go back into 8, and then we're gonna go probably here, like in over here. Yes, and I've just basically like copy pasted the private key into like the project, the folder of the project. Okay, good. Okay, so now we should just cd into the project. So we'll do like this. Okay. Okay, so now what we want to do is we want to connect with the server, and we want to copy the server folder on our local machine into the remote server. Good. Okay, so but the first thing we should do here is change the accessibility of our key, of our private key. So we should ensure that we are the only ones, like the owner is the only one who can like deal or like access the speech recognition.pem file, or like the private key. And this is just like a permission thing that you have to like ensure that works like this. Otherwise, like you're gonna get like an error from Amazon. Good. Okay, so we'll change the mode to 400, which is basically in reading mode only for the owner of the file. And then we'll specify that we want to change that on speech recognition. Okay, so that should be good. And now what we want to do is to SCP. So we're going to copy, and first of all we should use the I flag, and then this is used for specifying the key. And so we'll do -i speech recognition .pm, and here we should specify the folder that we want to copy over into the remote server. And so we'll do -r. And that's because we are dealing with folders, and so we have to use this recursive flag instead of simple individual files, right? And so here I'm gonna put server, and as the next step we should put in the Ubuntu @ and then we should copy in this public DNS address over here. So basically this means that we are connecting at this Ubuntu instance at this address, and here we'll put a colon and then use this symbol to say that we want to copy server at the home folder in the remote server. Okay, so let me run this command and see if it works. So here I should just say yes. Let's see if this works. Yeah, here we go. So it's working as it's supposed to, and it has copied all of these different files into the server. Nice. Okay, now let me clear the screen. Okay, so now let's log into the server. So for doing that, we are going to be using SSH, and basically the syntax to log into the remote server through SSH is very similar to what we did with SCP. So we're going to do a -i, and we're going to pass in the private key. And here, once again, we want to tell SSH where we want to connect to. So Ubuntu once again, we're going to be using this public DNS. Okay, so let's see if this works. Okay, here we go. So now we are into our Ubuntu remote server. And as you can see here, we have the server folder that we copied from our local machine. And so we can access that. Here we go. And yeah, and here we have all the things that are important for our speech recognition system application. So our docker compose.yml file, our Flask folder, and our nginx folder. And importantly, we have the init.sh, which is our initializer script. Okay, so we want to run that script. So in order for doing that, what we should do here is, first of all, we should do a change mode so that we can say that init.sh is an executable. So we'll do a +x, which makes a file executable, and then we'll just call init.sh here. Good. Okay, so now if we relist you'll see that this is in green now, this file, which basically means that it's an executable, it's executable, so we can execute it. That's good. Okay, so now the only thing that remains to do is actually to run the initializer. So we'll do /init.sh, and hopefully this should work. So let's start. Okay, so now we are running the update here, and then we should we are asked to install Docker. We'll say yes, and so now Docker is installing. We'll be installing Docker compose after that, and then hopefully we'll be building our containers and then starting them up. Okay, so we'll leave like this process like going, and it's going to take like, I believe, like a couple of minutes probably. In the meantime, we'll be working here on a couple of other things. So the EC2 instance that you create comes with a firewall, which basically means that you can't access like basically like any port apart from like port like 22, which is like the port that SSH uses for connecting to the server. So we want to change that because we want to be able to access port 80 on the server so that we can communicate with the server itself. Otherwise, like, it's completely unusable. So how do we do that? Well, we go here to this security groups, and this is like the name of the this security group here. Okay, and then we go here in this security group, and here you can see all the different inbound rules that we have like for our firewall. And as I mentioned to you, like the default option for Amazon instances is to only have SSH, so only port 22 open. So we want to open also port 80. So for doing that, we should do edit like this inbound rules, and we can add a new rule. And here we'll select HTTP, and it'll automatically fill the port here, which is port 80. And here, in terms of like the source, we want to say that the port should be accessible from anywhere. So basically, every IP, so from all over the world, will be able like to hit our server. And this is the way you open up your API to the external world, so that everyone can benefit from your amazing machine learning API. Good. Okay, so let's save the rules here. Okay. And let's check out like where we're at with this. Okay, so like I believe like we are still like we have like Docker Compose that's still like working and building like all the Python dependencies and things, just like to set up like these networks. That's quite cool. But we still have another thing that we should check out here. So if we go to local here, we have our client.py that, if you guys remember, is the script that we use for hitting the server so that we can get a prediction with a keyword directly from the keyword spotting service, right? Okay, but here the URL has like this localhost address here. Obviously, right now we don't want to hit localhost anymore. We want to hit our AwS server. So how can we change that? Well, it's quite simple. So if we go back to our instances here, so we can just take this, so the public IP for our instance, we can copy that, and then we can paste it in here, so that now the URL is going to hit like the public IP of like our AwS EC2 instance. Cool. Okay, so let's see if this is working. Yeah, great. So as you can see here, so the init file has done like its job, and now like it's working because like it has built these two containers, and now it has also like started up both like Flask and Nginx, and now like the we have like the server running. So hopefully, if everything like is working correctly, we should be able to hit the AwS server and get back a prediction about like the keyword that we are sending over. Let's run the client and see if it works. Okay, so we are already in this at the right folder. So if I do a list here, you'll see that we have this client.py. So I want to run that. So I'll do Python client.py. Let's see what happens. And here we go. We have our predicted keyword is left. And as you can see here, we hit the server with a post request, and Nginx received this post request. It forwarded that to the Flask container, and the Flask container sent back a response to Nginx and then to the client. So let's see this once again. And here you go. Yes, you've seen a new Nginx call, then Flask call, and then all the way back to the client, which basically means this is working. So you should really congratulate yourself if you followed so far, because we started basically from scratch with an idea, which was building a speech recognition system and then deployed it in a kind of production environment. And so we did all of that. So we built the speech recognition system, we deployed that as a Flask API, then we added UWSGI as an HTTP server, then we went the extra mile, put Nginx in front of that at UWSGI application server, then we containerized everything with Docker, and then we took all of that and put it into a server on AwS, which is great. Okay, so I really hope you enjoyed this video and obviously the whole series, and that you've learned a lot of interesting things. If that's the case, please remember to leave a like to this video and consider subscribing. So when you subscribe, also try to hit the notification bell so you'll be reminded when new videos come out. Now, if you have any questions about this video or the previous video, please feel free to leave a comment in the comment section below, and also let me know about topics that you'd like me to cover in the future. And I guess it's all for now. I'll see you next time. Cheers.